Hi there! So we are now on our third week, module number 3 for general mathematics. And the first lesson for this week's module is on the intercepts, zeros, and asymptotes of rational function. So first is the intercepts of rational functions. So what are intercepts? So these are now the points where the graph of the rational function intersects your x and y axis. So let's take this first example. Given your function equals f of x equals x minus 2 over x plus 2. So how do we find the intercepts of this given function? So we can have two methods, and that will be first algebraically and by graphing method. So in the first method, we find the x-intercept by letting your x be equal to 0, and you know that f of x is the same as y, so you can have also y equals x minus 2 over x plus 2. So substituting our x to be 0 here equals x minus 2 over x plus 2. Cross multiply, you will have 0 here equals x minus 2 on the right side. Therefore, the value of x that we got will now be x equals 2. And our x-intercept will be at 2, 0. Now, for your y-intercept, we do the reverse. We let this time x equals 0. So, substituting from our given function, so if x is 0, we substitute it here. So, y equals 0 minus 2 over 0 plus 2, giving us our y as negative 2 over 2, or simply negative 1. So, our y-intercept will be at 0, negative 1. So, that's the first method. Second method is graphically. So, we just locate points where the graph of the rational function intersects the x and y axis. So, from the same given, we just assign values of x. So, I have used here intervals of 2. So, you have negative 6, negative 4, negative 2, 0, 2, 4, 6. So, let's start. If your x is negative 6, so you will have to substitute your value of x, which is negative 6 here. Negative 6 minus 2 gives you negative 8. Over your denominator, negative 6 plus 2 gives you negative 4. So, simplify negative 8 over negative 4, that gives you 2. Okay? And if you have negative 4, so negative 4 minus 2 is negative 6 over negative 4 plus 2 is negative 2. So, negative 6 over negative 2 is negative 3. But if you have 2 or negative 2, what will be your y? So, negative 2 minus 2 gives you negative 4 over negative 2 plus 2 is of course 0. So, that will be undefined. Any number divided by 0 will have an undefined or indeterminate result. So, that will now be 2, 0. Okay. And this is related to the next part of the discussion. You will notice here the broken line. I will further explain that later. So, that's the value of y when x is negative 2. And you just continue finding the values of y from 0 to 4, 6, and we have these results. And graphing it already, you know already how to graph the or plot points of the Cartesian plane. So, ito yung result. Okay, so you will notice some graph will be here in the second quadrant, and there's a graph located on this part of the quadrant. Okay, so that's for your graphical method. The next now is your zeros. So what are zeros of rational function? The zeros of rational function is just the same as your x-intercept. Is it clear? Okay. So zeros is also known as your x-intercepts, or we also call that the solutions or roots of functions. So from our uh, discussion a while back, since zeros are also your x-intercepts, you follow the steps in the x-intercepts. So you let y be equal to 0. That's why you have here x minus 2 will now be x equals 2. That will be the 0 of your function. Or you can also have it at 2, 0. Okay, 2, 0. So that's your 0 of a rational function. Now the other part is the asymptote. So what is the asymptote of rational function? So asymptote is a line or graph or curve that approaches the graph without touching it. So it will just be nearly approaching your graph, but it will never touch it. And we have two types of asymptote. We have your vertical asymptote and your horizontal asymptote. For the vertical asymptote, we have two steps to follow. First is you are to equate the denominator to 0 and solve now for x. So from our example, f of x equals x minus 2 over x plus 2. So we use the denominator x plus 2. Equating that to 0, x plus 2 equals 0. So your x is at negative 2. So that's where the location of your vertical asymptote is, at x equals negative 2. So going back to our graph a while ago, okay, eto siya. So let's locate the vertical asymptote. So at x equals 2, so ilolocate nyo lang si x equals negative 2. So it's on the left side of your 0. Then from here, you are now going to draw a broken line. Okay, so you will notice the red line here that serves as your vertical asymptote at x equals negative 2. Okay. So that's the purpose why this result is undefined, because the location of our vertical asymptote is at negative 2. So this is the asymptote where your graph will just be approaching. So hindi niya malalampasan ito. Okay? Hindi lalampas yung graph mo dito. Same is true with the other graph here. So it will just be approaching. It will not touch. So if we are going to move infinitely down, so your graph here will just be approaching the broken line down. Okay, so that's your vertical asymptote. While for the horizontal asymptote, the horizontal asymptote can be solved considering three conditions. Okay, so the first condition is to notice the degree of the numerator and the degree of your denominator. So if the degree of your numerator is less than the degree of your denominator, the location of our horizontal asymptote is at y equals 0. Okay? Second condition, if the degree of the numerator is equal to the degree of your denominator, then your horizontal asymptote is located at y equals a over b. And what is this a over b? So a is the numerical coefficient of the numerators and b is the numerical coefficient of the denominator. third condition is when your n, the degree of your numerator, is greater than the degree of your denominator, we will not have a horizontal asymptote. Okay, so those are the three possible conditions that we need to consider in finding for the horizontal asymptote. So let's apply. Let's try to find the intercepts, the zeros, and asymptotes of the given function below. So if you are given f of x equals x squared minus 4 over x squared plus or minus 16. So let's start with the intercepts. X-intercept, so we said we have to find for x-intercept by letting y be equal to 0. So we let y be equal to 0. Okay. So 0 will be equal to x squared over 4, minus 4 over x squared minus 16. Okay, so 0 for y here, then cross multiplying, we are left with the numerator x squared minus 4, equating that to 0. And solving for x, so x plus 2 times x minus 2 equals 0. So we have here two values of x, negative 2 and positive 2. Sorry. So we have here x equals negative 2 and x equals positive 2. Therefore, our x-intercept will be at 2, 0 and 0, 2. Then, this will also be just the same your zeros. Okay? Since we have defined a while ago that zeros are also the x-intercept. So, x equals 2 and x equals negative 2. Next, for our y-intercept, so we let this time x be equal to 0 from our given. Okay, so we substitute here your value of x, which is 0, giving you y equals 0 minus 4 over 0 minus 16. So your y is negative 4 over 16, or simply 1/4. So our y-intercept will be at 0 and 1/4. Okay, and lastly, for its asymptote, so the asymptote, first is your vertical asymptote. So the two basic steps is for us to equate your numerator to 0. So x squared minus 16 equals 0. Solving for x, x plus 4 and x minus 4 are the factors, equals 0. So your x will now be at negative 4 and positive 4. So those are the vertical asymptotes. So dalawa ang vertical asymptotes natin, at negative 4 and positive 4. And for the horizontal asymptote, so consider the degree of your numerator and denominator. So you will notice here they are both having a power of 2, therefore the degree are equal. So n equals m. And so our horizontal asymptote in this case will be at y equals a over b. So we try to see again the numerical coefficient, which is 1 over 1, or simply 1. So that's how you're going to find the horizontal asymptote for the given function. So I hope with this example I have let you understood further our lesson on the intercepts, zeros, and asymptotes of rational function. Thank you for listening. See you again in the next video.